Hi, my name is Mike Burnett, and in this video we'll show you how to build your own DIY heat pulse velocity sap flow sensors. This video should be used alongside the tutorial at michaelbird.net, and I also recommend reading the 2022 paper by Justin Bezlity that we based our design off of. We'll start with the data logger. You can print your own PCBs using the design files on my website. Start by soldering the 9 10K resistors. It's important to get these laying flat on the PCB so they don't block the other components. You can either use helping hands or lay the PCB upside down on the table. When you've finished, trim off the excess leads. Next, you'll solder the 1K and 100K resistors, and then the wire terminals. After that, move on to the progressively taller components, making sure that you orient them correctly. Now it's important to test the remaining components. Because we're using cheap breakout boards to record and write the data, we want to make sure they all work and are able to talk to each other. First, we'll upload the configuration script, which sets the clock on the logger. You may see the blue LED turn on after this is uploaded, and the serial monitor on your computer should display a message with the current time on the data logger. Next, you'll connect the D3 pin on the microprocessor to ground, hit the reset button on the logger, and then upload the test script. Once the test script is uploaded, you can unplug the USB cable, disconnect D3 from ground, plug in the battery, and hit reset. The blue light should turn on within 60 seconds. Now that you know this set of breakout boards works with each other, transfer them to the PCB and solder them. There are two identical ADS1115 analog digital converters, and you'll need to keep track of which one was tested as ADC1 and which one was tested as ADC2. And this is your finished data logger. Next, we'll build the two thermistor probes. You'll need to look at your steel needles and figure out how long to make your thermistors so they sit at the desired depths within the tree. If you have 4 measurement depths, you'll bend each thermistor's leads at one of 4 lengths. Now, thread them one by one into the steel needle, such that the bends all rest on the rim of the needle base. Start with the longest and proceed to the shortest. Use a drop of superglue to hold them in place, and if you have it, you can use accelerant to cure the superglue instantly. You can either fill the needle completely with thermal epoxy, or use thermal grease to make it easier, as we do here. Fill the needle with grease until it comes out of the end, and then mix a batch of the thermal epoxy and fill a syringe. You want to inject enough thermal epoxy to hold the thermistors and grease in place. I like to push out 1 to 2 centimeters of grease, but try not to push any air bubbles in. Cut off several feet of multi-conductor cable. On the end, strip off about 2 inches of the exterior insulation, revealing the wires inside. This will be the end that plugs into the data logger. So you can strip a couple millimeters of insulation off of every wire. On the other end, strip off several inches of the outer insulation, and then cut the individual wires so that each thermistor has a pair that's the right length. I recommend picking colors that are consistent for each probe. For instance, I use black and white for the deepest thermistor and red and orange for the shallowest thermistor. You want to strip a bit more insulation off of these wires, say about 15 millimeters. You should end up with staggered wire pairs that match the thermistor leads. Before we solder, we burn some of the insulation off of the leads and cut some pieces of tiny heat shrink tubing. Then, put the tubing on a pair of wires, wind the leads around them, and solder them together. After soldering, use a multimeter to make sure the circuit is good. Use a heat gun to shrink the tubing, and finally add the external heat shrink tubing to seal it all up. I prefer to just heat shrink the ends of this tubing, leaving the middle to be more flexible and allowing you to make repairs down the road. We don't show you how to build the heater probes in this video, but much of the soldering work is the same. I encourage you to check out our website to see this in more detail. To prepare the case, drill a hole that's the right size for your cable gland. I use a step drill that can drill through the plastic. Insert the cable gland, making sure it's a tight fit, and lubricate every surface with O-ring grease. On these sensors, I'm adding an extra internal gasket in addition to the black external one that came with the gland, but this may not be necessary. Using sufficient O-ring grease is key for waterproofing. You must also make sure there's no debris lodged in the gaskets that could allow water to get into the sensor. Screw all the parts of the cable gland together, making sure everything is fitting tightly. Attach a desiccant pack and some Velcro straps into the case that can hold the battery in. Then, insert your 3 probe cables. If you use a 3-hole cable gland like we did, you must be careful to buy cables that are all the appropriate diameters. Once the cables are threaded through the gland, you can screw them into the data logger. For the 2 heater wires, the polarity does not matter. It also doesn't matter if you attach them to the H1 or H2 ports on the data logger. Next, you'll screw in the thermistor wires. Keep track of which probe goes into slots T1 through T4 and which goes into T5 through T8. For each of the probes, the color order should be the same if you followed a consistent scheme. The polarity does not matter within each pair of wires that leads to a single thermistor, so technically I could swap the red and orange with each other or the white and black with each other. Once the sensor is all ready, you can go ahead and insert the battery. I like to plug the battery in and then slowly lower the battery into the case, fasten the Velcro belt, and then seal the box. The sensor is now ready to be programmed and deployed. I hope you enjoyed this video. If you're interested in analog voltage data loggers that can be used with a variety of sensors, including microtensiometers, please check out my website. Thank you very much.